So very good morning, children. We're sorry about the little delay that happened. There was some inconveniences, electricity issues at BHU there. So we have our Mr. Ramanathan here. Let us commence today's program by a prayer song by Master Jayasuriya from Chinmaya Vidyalaya, Kunnumpuram.
Vande Mataram Ambikam Bhagavati Vani Rama Sevida Kalyani Kamaniya Kalpaladiga Kailasanatha Priya Vedanta Pradipadyamana Vibhava Vidvan Manoranjini Shri Chakrangida Rakna Pida Nilaya Shri Rajarajeshwari Shri Rajarajeshwari.
Let us thank our Master Jayasuriya for this wonderful prayer. So let's put, we are very, very happy that we have Professor Dr. Ramanathan with us today to take today's session on chemistry in India. As I had already briefed you, sir, knowledge, tradition, practices in India is a subject introduced by CBSE on the systems of India's glory and all of that for the class 11 and 12 standard students. And Chinmaya Mission is promoting the subject because there are not too many schools are active going in for it, and CBSE has a concern also. So we have been doing sessions. Last year we conducted about 7 sessions for the class 12 students on the various speakers, eminent people came and addressed them, and they took them beyond the textbook. And this year there was a lot of requests from schools to take it up on the class 11 chapters. So we are now, this is the 4th session we are having. We had already 3 sessions on some of the chapters. Now the CBSE has also revised the pattern in such a way that there are 4 chapters which are there only for projects. The rest will be tested on the examination and tests and written test. So chemistry in India is one of them where children can do a project, because they are trying to make children other than science students also take up KTPI. So their children can explore, do a research and prepare projects in a few of the chapters. So there are 4 chapters they have been allocated for projects. Children can do one of them, select one of them. So mathematics in India and chemistry in India, and there are 2 more topics which are kept for projects. So today's topic is for that, and it's going to be really enlightening for the children, because they're all taking down notes and they're utilizing it for their own projects work, what they're doing, where they can do a lot of additional work other than given in the textbook. And you can see that some of the children are seated in a classroom setup. We have about 120 people here. And that is the background behind the program. And we are very, very thankful to you for accepting to be part of this wonderful knowledge program, knowledge sharing. Children, I request all of you and the teachers to have your videos on, so that it will facilitate the speaker to have a complete communication very easily. And I'm very, very happy to introduce to you Dr. V. Ramanathan, Assistant Professor, Department of Chemistry, Indian Institute of Technology, BHU, Varanasi. He's a physical chemist he's very, very versatile in the laser spectroscopy, Raman microscopy, and computational chemistry. After doing his PhD from the IIT Kanpur, he has his postdoctoral experience in Seoul in South Korea, Basel in Switzerland, and Stuttgart in Germany. He has almost 44 publications to his credit with 470 citations. His current research is in the surface enhanced Raman Scalary and applying Raman imaging in biology and medicine. His academic interests include a lot of the ancient science and medieval Indian concepts and theoretical aspects. He's also interested in the theoretical aspects of Carnatic classical music, and he is a Fulbright scholar and was a member of the National Core Committee of INIAS, a body of INSA, Indian National Science Academy, and that is Mr. Dr. Ramanathan, and we are very, very grateful to him for having accepted our invitation and address the children. Over to you, sir.
Thank you very much, ma'am. And although you apologized on my behalf, apologies are due from me for this inordinate delay due to some issues that are beyond my control.
And we do understand, sir. We do understand.
That apology, I thank the Chinmaya Mission for having given me this wonderful opportunity to interact with the final stakeholder of whatever we are trying to achieve through this NEP and stuff, that is the school students. So today's session being chemistry, I took liberty to slightly expand my title, Bharat's contribution to chemistry, material science and metallurgy. So because chemistry as such, even until the recent past, is an all-encompassing subject, included metallurgy and material science. Of course, in the medieval and the ancient times, it did have that vast reach. So with that approach, I'll be covering some aspects, giving you the glimpse. And whatever I cover is over and beyond the KTPI chapter that is prescribed for the textbook. So I hope my screen is visible to all. So in the true spirit of the Jnana Yajna that Guruji had started, I like to dedicate this talk by a humble offerings to him. Jnana Yajnam tu samsthapya Vishwa Kalyana Karine Vande Shri Chinmayanandam Sachidananda Vigraham. So it is in that spirit of Jnana Yajna that when ma'am also introduced this talk today, this is this knowledge Yajna that we are continuing the saga with which Guruji had started his spiritual mission and enlightening the world. So I see it in the same spirit, and I see it as an opportunity to be a part of this Jnana Yajna. So this will be my brief outline for the next 1 hour or so. I know 90 minutes has been allocated, but already I have wasted 20 minutes. So I'll not bother you much. I'll try to wrap it up in the next 1 hour or maximum 70 minutes. I'll be giving you some introductory remarks and giving you some metallurgical highlights by taking few metals, namely gold, iron, copper, and zinc. When I'll be dealing with copper, I'll be also talking about its alloys, namely brass and bronze. Then I'll be giving you a few highlights from a prominent chemistry texts. And if time permits, we'll get into contemporary relevance. But although this is at the school level, so we will not get into the... If time permits, we will see. Otherwise, I'll conclude by giving concluding remarks. So, whether we like it or not, we still are having the colonial hangover, where unless a foreigner comes and gives you some gyan, we are not in a position to receive it in a very positive way. No matter how many Indian scholars come and interact with us, come and talk to us, it's always seen as something not of that impactful compared to somebody from a foreign soil speaking to us. So in that spirit, I also begin my talk with some quotation from a foreigner, and no less than somebody called William Ramsay, who is a Nobel laureate. And all of you must be knowing that now we are approaching the month of October, where this Nobel fever is going to start, where every week we are going to see one announcement for the Nobel Prize. So it will be also good exercise to all of you to also guess who may be this year's Nobel Prize winners in different subjects. So William Ramsay has been one of the Nobel laureates in chemistry. And this is what he had to say about chemistry. And I quote him: "The country which is in advance of the rest of the world in chemistry will also be foremost in wealth and in general prosperity. So keep this in mind. So it's of his opinion that so this was of his opinion, his statement that the country which is in advance in chemistry will be leading also the world in terms of material prosperity. Now, this is not a sentence which is out of plain imagination, or this is not a product of some fertile imagination or creativity. What I did is I just took collated the data of the number of Nobel laureates in chemistry in the last 120 years or so, and then also tried to see if there is any correlation that exists between the number of Nobel Prize and the GDP. What is GDP? GDP is a measure about the prosperity of any country. If the GDP is high, gross domestic product, if that is what is GDP. If the GDP is high, then we understand that the country is a rich country. If the GDP is low, then the country has to improve on its economic dimensions, which means it has to either generate more revenue by production or by managing the infrastructure, so on and so forth. So GDP is one such measure to talk about the richness of the country. And what do we see here? We see a direct correlation. You should understand in class 11, you may not come across the term correlation, but in science, there are two different aspects. One is causation and the other one is correlation. Causation is something A causes B, like a viral infection causes fever. So we can clearly establish the cause and effect relationship. That is called causation. Whereas correlation is something that two incidents occur parallelly and one may not be the cause of the other. Say, for instance, the sky was completely blue during the lockdown time. Now, we cannot say the lockdown has caused the sky to be blue. It was a correlation. So similarly, you can see a correlation between the number of Nobel laureates in physics and chemistry and the GDP of any country. So whatever William Ramsay had to say about the material prosperity directly correlated with advanced knowledge in chemistry is backed up with some kind of an empirical data. Now I want you to pay attention to this graph. This graph was generated by somebody called Angus Madison almost 20 years back from United Kingdom. He was an economist and he was asked to calculate the GDP of all the countries for the last 2000 years. See, in the news, you may always be listening that Prime Minister is aspiring for a 5 trillion economy. That is, our GDP has to be of a double-digit figure. Currently, it is still in single digit. So GDP is something that has to be calculated, and there is a whole lot of technique that goes behind calculating the GDP. You can talk to your economics teacher or friends who are in economics group more about this GDP. But as Angus Madison was asked to calculate the world GDP for the last 2000 years, and this is what he had come out with. So I want you to pay particular attention to the orange curve, which belongs to India. Now, if you see, almost until 1600 or so, India was kind of leading, at least till 1500, India was leading the world GDP. Almost 30% of the world GDP was contributed by India. Okay. And at that time, the USA was barely scratching the bottom. But as time progressed, We know what had happened in the second millennium after 1000 AD. Several invasions, several attacks, several trade establishments were there. Eventually, our GDP has been constantly reducing. And now we are somewhere below 10% mark. Now I would like you to ask this question for yourself, that what attracted people from all over the world to India? Were they interested in tourism? Were they interested to come and take some education from our country? Did this bring the invaders and the traders from all over the world? It might have, but those numbers must have been very, very small. The large numbers were attracted by the material wealth that we were producing. Either we were extracting from the nature or we were processing them, and that's how we were advanced in our material wealth, which attracted our neighbors from far and wide. So now, and the William Ramsay's statement is what I'm using here to establish the fact that we were very good at chemistry, material science, and metallurgy, and that must have been the reason for our enhanced GDP, which resulted in attracting the neighbors from far and wide. So with that introductory remark, I would also like to make it very clear that today what we teach and what we learn in school and colleges as chemistry is modern chemistry, which had its birth somewhere in the second half of 18th century and from advanced by the European scientists, to name a few like Joseph Lavoisier, Antoine Lavoisier, Joseph Black, Henry Cavendish, so on and so forth. So today's chemistry that we study are a product of the chemistry that has advanced in the last 200 or so years. Whereas when I talk of Indian chemistry for the next 1 hour, that will be all-encompassing multiple fields, which are pragmatic in nature, something very practical in nature, like say your pottery, brewery, dye, metalsmithy, glass making, so on and so forth. So in terms of contribution, these are the limited but not exhaustive list of contribution that Indian chemistry has had in the ancient and the medieval times. So you can think of any day-to-day object and you will find contribution from Indian chemistry. That is true even today, that from the morning till the night that we use, there will be some aspect of chemistry that is associated with all the products that we use right from morning till the night. But this will be something, this was something very interesting when I came across at least a few years back as a student of chemistry. So we all know that science has got lots of foreign words. And especially if you're a student of biology, you will be very well knowing that a lot of Greek and Latin words are appearing in the subject. For instance, Homo sapiens itself. So why do you think science retains foreign language words in it? It is to acknowledge the source, the origin of the knowledge from which the modern science has evolved, and to establish that kind of a link. It is not to cut the link from the roots from where it evolved. That is why even modern science has got the terminologies retained which are borrowed from the foreign language. But as a student of chemistry, it was very surprising for me to learn that even today we use certain terms in chemistry that are directly borrowed from Sanskrit language. For instance, the word corundum, which is used for a mineral, directly comes from the Sanskrit word kuruvinda. And similarly, the words for minerals like beryl and beryllium comes from the Sanskrit word veluri. If corundum, beryl, beryllium are not very commonplace, I am sure you have used or you have heard the word sulfur quite often in your laboratory class or somewhere in the text. And the very word sulfur itself is a Sanskrit word, slightly derivatized form of the Sanskrit word shulvari. Okay. More about this word I'll tell you later, because shulvari is a compound word. Shulvasya arihi iti shulvari. Now what is shulva? Shulva is copper. Shulvasya arihi, the enemy of copper. Arihi means enemy. Why is sulfur considered to be copper's enemy? Because those days they were checking the reactivity of different substances using sulfur. And they found that copper is one of the most reactive substance. Copper readily reacted with sulfur. So they termed sulfur as copper's enemy. That's how it got its name, Shulvari. And from Shulvari, we have the word now, sulfur. So even today we use these terms which are direct import from Sanskrit. And when science uses words from a foreign language, as I said, it talks about the origin of that knowledge, which means this is also clear evidence to show what has been the highest achievement of our ancestors, so much so that they could lend the words to science which are in currency even now. There is always a criticism that we do not have many textual evidence. Many of the things that we speak are out of fictitious imagination or product of very fertile creative imaginations and so on and so forth. But at least there are hundreds of texts which are directly related to chemistry, and some of them are in direct. I have myself collected them because they're available in public domain today. And in this talk, I will be highlighting these two texts which are of quite importance and relevance to even the discussion that we are going to have today. Namely Rasaranava and Rasaratna Samuchchaya. But talking of metals, this is a verse from Krishna Yajurveda. Hiranyam chame, ayashchame, sisam chame, trapushchame, shyamam chame, loham chame. So now it talks about 6 different metals at the same time. Hiranya, aya, sisa, trapu, shyama, and loha. We understand the metals by their English names today, where we recognize Hiranya as gold, aya as silver, sisa as lead, trapu as tin, shyama as iron, and loha as copper. Mind you, many of you who are Hindi speaking would immediately find it difficult to believe me, because loha today refers to as iron. But over a period of time, loha has come to become iron. But actually, loha means something that is reddish in color, lohita. Loha is reddish in color and copper is reddish in color. So that's why copper gets the name loha. Similarly, shyama is something that is quite dark, because iron is quite dark in color. So iron gets the name shyama. So, there are a lot of linguistic difficulties in arriving at the correct meaning today, what they mean, but I will not bother you with the linguistic underpinnings of these. But what I want to convey the message is that in the Krishna Yajurveda's time, we have explicit mention of 6 different metals. Now, this has got some bearings with history also, because in history, I am sure in class 6 or 7 you must have studied, and you might recollect even now that history divides the human civilization into multiple ages and stages, namely Stone Age. So where again it is classified as Paleolithic Age, Mesolithic Age, Neolithic Age, and then once the Stone Age is over, then the Metal Age begins. And the Metal Age begins from Copper Age, then Bronze Age, then Iron Age. Then what we are currently living in is either Silicon Age or garbage. That I leave it to you to decide upon, depending on which perspective you are looking at. But so what I want you to carefully recollect is that copper comes first, and then bronze, and then comes iron. So there is at least a gap of 500 to 1000 years between copper and iron in this periodization of civilization as propounded by the European scholars. Now here we have in Krishna Yajurveda a simultaneous mention of iron and copper. Now this could only mean two things. One, that this verse was composed after Iron Age, because once you have an Iron Age, you will have both copper and iron at your disposal. It could only mean that this verse was composed after this Iron Age, or it could also mean that this kind of a linear periodization is not applicable in the Indian context. And there are various other evidences to show the second point being more prominent, that this kind of a periodization is not really relevant in the case of Indian context. But more on that at a later date, because that's not the actual subject of chemistry. This has got underpinnings in history and archaeology. But I want you to, as an impressionable mind, I want you to think about it, not just directly consume what the history textbook has informed you. Now, talking of gold, gold is one of the most important metals. Even today, it's of very high importance. And needless to say, not just the Indian civilization, but civilizations across the world were obsessed with gold, so much so that gold was the very first metal for all the civilization to lay their hands upon. Despite the fact that gold is quite rare on the Earth's crust, what I've shown you is the distribution of metals in a pie chart where you don't find gold at all. You find maximum oxygen followed by silicon, and gold is somewhere less than 0.2% in the others category. Now again, this is the vertical dimension of the Earth, and people normally do not go more than few kilometers below where we are living. So you can see how difficult it is to mine out gold. But despite that, all the civilizations across the world have been successful in mining out gold, and not just mining out, and also processing them. Gold, as you may know, is not always found in its zero oxidation state. Those of you who are not from science, oxidation state is a property of every atom, where if the atom is having adequate number of electrons, it is neutral, it is not reactive. But for chemistry to happen, either it should give away the electron or it should take electrons. So when it does any of these two, then there is something called the oxidation number which changes, and more often the metals in their natural form are found in their positive oxidation state. So is also gold. So we need to supply electrons to those ore and reduce those oxidation numbers to zero, so that we get the metals in their native oxidation state, in their zero oxidation state, and that is where they'll be able to get processed into some meaningful objects and artifacts. Now, it's a quiz time that I would like to ask the students. You see in front of you a shloka, something written in Sanskrit. I read it for you. Jambunadam, Shatakumbham, Hatakam, Vainavam, Shringashuktijam, Jatarupam, Rasavidham, Akarodgatam cha, Suvarnam. Kinchalkavarnam Mrudusnigdham, Anari Bhrajishnucha Sreshtham, Raktapidakam Madhyamam, Raktaswar. 1 second. Yeah. So can you guess what I don't want you to guess the meaning of this, but I just want you to guess which is a text from which I have taken this text, taken this verse. Can you make any guess?
Yeah, you can unmute and speak, children. You can unmute and speak.
Nobody would like to take a guess? I am sure your teachers are not going to punish you if you are giving a wrong answer.
Sir, Ramayana.
Thank you for guessing, but I am sorry it's wrong.
Sure, sir.
Any one more brave student to make a guess?
Sir, Bhagavad Gita.
Thank you for making a guess, but I'm sorry, it's not from Bhagavad Gita. See, that is, I am trying to make a point here, that today we have come to such an extent that anything that is
Somebody
written
is saying is it from Agni Purana? They have messaged in
Agni
chat
Purana,
box.
again a very good guess, but I'm sorry, it's wrong. Something that is written in Devanagari today, we immediately act. Yes?
Charaka Samhita, sir.
No, you are quite close, but I'm sorry, again, it is not from Charaka Samhita. But I'm happy that at least one guess has come.
Sir, Sushruta Samhita.
I'm sorry, again, you are quite close by, but no. But at least there are two guesses which are not from religious texts. This
Someone
is
is saying, is it Ashoka Pillar?
No, this is not from Ashokan Pillar, no.
Oh, yeah, that's another guess come.
No.
Arthashastra has come. Article
That
safety.
is the correct guess. So
The
I'm
Chinmaya
happy.
Vidyalaya article student has given that.
Very nice. So this is from Arthashastra, okay, by Kautilya or Chanakya.
Oh, Chanakya.
So people normally think that Arthashastra is a text on political science or economics, but I would like to inform the students that the whole of second chapter is on chemistry, metallurgy, and material science. So this one verse which I have taken, it talks about different types of gold in it, and which is the better gold, which is a inferior gold, superior gold, so on and so forth. Okay. So today, I'm sure this is for more from science students, that in the chemistry as well as in the physics, they study something called a phase diagram. I'm sure those of you have not yet come across in class 11, the phase change chapter. I'm sure you have the phase diagram for water. This is a single component phase diagram. I'm sure you do not have two component phase diagram in the school, but the moment you go to higher studies, you will come across two component phase diagram. What is the two component phase diagram? Suppose what is an alloy? Alloy is nothing but a solution of two different solids. Two different metals, if you mix, they become solid solution. And how to know the proportion in which I have to mix the solid so that I get a homogeneous solution. In the case of liquid and solid, I know. Suppose I have water and I want to make a sugar solution. I add 1 spoon of sugar, I stir it, I get a saturated solution. Beyond that saturation, if I add more sugar, how much ever I stir it, sugar will not get dissolved. Sugar will always remain as a precipitate in the bottom. Then if I slightly increase the temperature, then that sugar may get inside the solution and I get a super saturated solution. Right? So in the case of liquid and solid, we know it. But what about in the case of solid and solid? Suppose I want to make gold and copper solution. Today we know it through what we call it as a phase diagram. That is, if I have this phase diagram in front of me, that is, if I want to get to this place where this first arrow is, okay? Just a sec. Yeah, so here, Suppose I want to make a composition which is roughly, say, 80% copper and 20% gold, which means I need to go to this temperature. So this is the information I get from a phase diagram readily. So I'm not saying that Arthashastra knew about the phase diagram, because it talks about how many ever types of gold. It talks about these many types of gold that I showed you in the previous shloka. 10 types of gold. And it further says that Tata Shulba Kakunya Uttarapasarita Chatussimantaditi Shodasha Varnakaha. He says the text talks about 16 different colors of gold. Okay. So now that is only made possible if I have different kind of alloys. And not just that, it talks about how to detect, because now if you mix copper of different proportion, the gold quantity is getting changed. Today, the ornament gold that people wear today, that is available in the market, maximum is 24 karat. But that is not what is used for ornaments. For ornaments, what is used is 22 karat. But 22 karat means it is 92.6 percentage gold and 7.4 percentage copper, or 91.6 percentage gold and 8.4 percentage copper. Now, how to test whether this is really 22 karat gold or not, or is it really inferior gold? That is also discussed by Chanakya in the Arthashastra, and that is something which we see even today in any gold shop, even in a small village, that the goldsmith will take a stone and he will rub the gold again, on the stone, and then he will add something to it and then test the purity of the gold. So very interestingly, in the text, Chanakya describes a whole chapter where he says that if a goldsmith is trying to cheat you by selling an inferior gold in the cost of a superior gold, then what kind of punishment should be given to that goldsmith? So you should understand that back then when Chanakya was writing the Arthashastra, people were there even then to cheat others by selling inferior gold as superior gold. Now, this is a description of a solid state reaction. Those of you who are in chemistry will be able to understand that most of the chemistry happens in liquid state. You need some solvent. Otherwise, the reaction will not proceed. So, but here is one description of a solid state reaction to purify the gold from its ore. That is what is described here, whose English translation is given in this manner here. I'll not bother you with the details of it. So much about the gold part. Next, we'll move on to the next metal, which is iron. Iron has been, India has been the pioneer in producing rustless iron for a very long time. One of the best examples, those of you who are in the North India and those of you at Delhi, I'm sure you must have seen the iron pillar at Mehrauli, which has stood the test of time at least for the last 1500 years without any rust. There are many such pillars like that, and these bear the testimony to the fact that our ancestors were able to produce iron of very superior quality that did not rust for a very long time. Today, the situation is such that I'm sure any building that is erected, they will have iron reinforcement, and within 1 year or 2 years, the building start developing the crack because the iron inside that has got rusted already. So now compare this to the technology that was there 1500 years back. But very interestingly, there is a description of iron in Rigveda. Rigveda has got this verse where I will just read it for you, the second line especially, that Sadhyo Jangam Ayasin Vishpalayai Dhane Hite Sartave Pratyadhattam. So here, the context, the background behind this verse is that a battle is being described. Now, in that battle, the warrior queen named Vishpala, although there is some kind of a dispute whether Vishpala was a warrior queen or was the name of a horse. Let that debate as it be. This warrior queen, Vishpala, while fighting in the battle of Khela, had lost her leg, had injured her leg. And immediately, overnight, she was given a prosthetic iron leg. So, and she continued with the battle from the next day. So here we see a clear description about a prosthetic iron leg, Jangham Ayasim. Now, Ayasi, Ayasa, Ayas are synonyms taken for to refer generic metal, or some people have taken it to refer to specifically iron. Again, Arthashastra has got copious description about processing of iron, because iron was a choice metal for warfare, whether to make a shield, whether to make a sword. So like iron swords, arrows, they were called as Shatagni, axes, spades, breastplates, armor, so on and so forth. So you find copious description of iron, processing of iron in the text of Arthashastra again. What I want you to pay attention to this map is the arrows that I have indicated. So you can see here it's all the way from the north, from Delhi till Tirunelveli in the south, Dwaraka in the west, to Puri, to Bhubaneswar in the east, and few places in the central part of the country. So when archaeologists made some excavations, they discovered iron artifacts from these places, and they discovered that these artifacts were more or less identical in nature and their makeup. Now, this could only mean that either these artifacts were getting made centrally and were getting distributed, or there was a pan-Indic knowledge to process iron that was spread across the country. Okay, one of only these two possibilities would result in such a kind of a finding. Of course, I mentioned about the Delhi's iron pillar, so I'll not repeat about that. What you see here is called as a Damascus sword. Unlike today, where swords are only used for decoration purpose in some homes, back and even 100 years back, swords were of active demand because battles were fought on ground physically, where you needed to vanquish, to overpower the enemy physically. And in that, swords were of most important weapon, and the swords had to last for a very long time. It's not that if one head is cut using the sword loses its sharpness and somebody needs to again grind it or sharpen it in the war field. That's not practically possible. So a sword has to have long-lasting sharpness, and that was exhibited by this Damascus sword. Damascus, by the way, is the name of a place in Greece near Syria. Now, this Damascus sword was made out of a steel called Wood's steel. Interestingly, the word woods in English spelled as W-O-O-T-Z comes from the Tamil word urukku. From urukku, it becomes to a Kannada word, and then it becomes to an English word. Now, urukku, as you may understand in the Tamil parlance, it is something that is to melt. So, basically, the wood's steel is a special steel. By the way, what is steel? Steel is nothing but iron with some amount of carbon in it. So when you are melting iron, if you mix some amount of carbon to it, you get steel. But the golden question, or $1 million question here, is how much of carbon has to be added to the iron to make it into a wood's steel? That's a very challenging part, because the window is very narrow. between 3 to 4%. Less than 3%, this will not show the property. More than 4%, it will become too brittle. So you have a very narrow window in which people had to engineer to add the precise amount of carbon to the melted iron, and thereby make the Damascus sword. I'll not bother you with the historiography. That's something not meant for your school level. And the next metal that we have to really pay our attention to is copper. And as I mentioned, copper had come first, then came iron in the European soil. But in our country, the copper and iron artifacts were found perhaps simultaneously. Excuse me. In talking of copper, although you may not be able to see the names very clearly, but I have listed in front of you at least more than 100 names of cities in the ancient and medieval India where copper was processed in large numbers. So you can find all the way from north to south, east to west, copper was kind of processed. And copper, unlike iron, is kind of more difficult in order to the durability point of view. Copper is a more difficult metal than iron because copper reacts very quickly. Those of you who have had the habit of wearing some copper amulet or copper kada or copper bracelet, you must have noticed that very soon it gets discolored. In some green patches or a blue patches start getting formed on the copper artifact. That's because copper gets converted very quickly to its oxide or to its sulfide in the presence of nature. So despite that, you see such a big colossal statue, more than 6 feet tall, copper statue was excavated from a place called Sultanganj in Bihar. This was somewhere in 1850s, and Alexander Cunningham, I think he was the one who was excavating it. And then now currently it is resting securely in the British Birmingham Museum. And this is more than 99% pure copper, and it has not shown any sign of reaction or rusting, which really is a testimony to the extreme perfection of copper metallurgy exhibited by our ancestors. When we talk of copper alloys are also equally important, namely brass. Brass is referred to by various names in the Indian language, like in Malayalam and Tamil, it is referred to as pittala, pittalai. Hindi also it is referred to as pital. But in the text we come across different names of brass, namely Riti, Ritika, Pittala, Arakuta, Ara, Swarnaka Krita. So these are the different names. And when you have different names for the same substance, that has often led to confusion for later year scholars while making sense of the text. This also I would like you to keep in your mind. From chemistry point of view, the atomic size of copper and zinc are more or less similar. By the way, brass is nothing but a solution of copper and zinc. And since their atomic sizes are nearly comparable, the alloy, making alloy with copper and zinc is much more easier. When it comes to brass, there are two different ways by which brass can be made. One is called the intentional brass and one is called the accidental brass. What is accidental brass? See, when copper is getting processed, back then people did not have the technology to differentiate which is copper ore, which is zinc ore, which is tin ore. So whatever ore they could lay their hands upon, it was processed together. And depending upon the melting point of these metals and depending upon the atomic sizes of these metals, they formed either different metals or they form the alloy. So it's such kind of a brass formation is called the accidental brass formation. But in such a case, you will not be able to make brass which is more than have zinc percentage more than 20 to 25%. But in the case of intentional brass, the zinc percentage of zinc can go very high, more than even 30%. So that begs a larger question as to how did our ancestors process zinc? Because all said and done, today, whatever technology appears in the West, we follow suit. But as far as zinc is concerned, Europeans did not know zinc till 18th century, 17th or 18th century. But we were knowing zinc at least 1,000 years before the Europeans. So the larger question that looms is, how did our ancestors process zinc? That will be more interesting. So I'll not bother you with this part over here. We have evidences of brass being used right from our Vedic texts. Like here I'm giving you one example from Atharva Veda, where the word Pittala appears, Tadaha Vaishvanaram Pittalam, Tada Ashvina Viveshatamiti. Similarly, in the case of Katyayana Shauta Sutra, which is another Smriti text, you find the word Pittala appearing here, which means Pittala was very much in vogue during that time. And interestingly, you also find the word Swarnakrita. The word Swarnakrita, you might, with your bare minimum knowledge of Sanskrit, you'll be able to make the sense that something that is appearing like gold. Why? Because brass, if you look at the process of making the brass, in the initial stage, the brass glitters almost like a gold. That's why it is also referred to as Swarnaka Krita. Again, phase diagram. Today we understand it, but back then people did it in a hit and trial method to make the brass alloy. Coming to bronze. Bronze is an alloy of copper and tin, another metal. Unlike zinc, the tin's atomic structure is slightly different. So making bronze is much more difficult than making brass. But nevertheless, this was made by our ancestors right from the Harappan period, which is this dancing girl of Harappa, very famous, made immortalized in our history textbook, in the NCERT textbook class 6, where her picture is always shown no matter which edition of NCERT we take it up. Down to this day, and these are Chola bronzes that are made even to this day in a place called Swami Malai near Tanjavur in Tamil Nadu, where artisans make such bronze figurines even to this day using the same technique. And interestingly, the technique that they use, although in the English textbook it is referred to as lost wax method, this is called Madhu Uchishthana Vidhi. So how do they make it? How do they get such fine drawings on the sculpture? They make it first using a wax model. They make such fine design on the wax, and then they cover the wax figure with very fine clay. And then when they cover the wax figure with a very fine clay, they make a small hole on the top through which the molten metal is poured. When the molten metal is poured, what happens is the wax is melted away, and wherever the wax has melted away, the metal takes those places, and that's how you get the figurines. And this technique was invented in the Harappan times, and it is being followed even to this day without any much of change. Now I'll switch gears and I'll talk about some of the prominent texts namely the two texts, or no, the zinc, the last metal which I wish to deal with is a zinc metal. And zinc is, as I told, is a very interesting metal because Europeans did not know it until 17th or 18th century, whereas we were processing it at least 1,000 years before the Europeans. Now, if you look at the terminologies, the names in Malayalam and Tamil, today it is called as Tuttanagam. And in Chinese, it is referred to as Tuttanag. In Sanskrit literature, it is also called as Tuttha. Besides Tuttha, it is called as Yashada. Yashada becomes Jashada. And Jashada in today in the northern India, if you call, it is called as Jasta. So Yashada becomes, so Yasham Dadati iti Yashada. Again, zinc is also quite a lustrous metal. It appears like a silver. So it is Yashada. The Yajayor Abheda, that's why Ya and Ja you find interchangeable in our Sanskrit language. That's why in some places she is referred to as Yashoda, whereas if you go to Gujarat and all, the word becomes Joshoda. Ya becomes Ja. So Yashada becomes Jashada and Jashada becomes Jasta in the common parlance. So today in the North India, zinc is referred to as Jasta, and whereas in South India, especially in Tamil and Malayalam, it is referred to as Tuttanagam. Now, Tuttanagam is also referred to for copper sulfate, Mayil Tuttam. And same Mayil Tuttam in Malayalam is also referred for copper sulfate. So, how did they make zinc? Making zinc is quite an interesting process because of the vaporizing nature of the zinc liquid metal. So once you liquefy the liquid metal has got the tendency to vaporize quite quickly. So you cannot melt or you cannot process the zinc in an open furnace. You have to have a closed furnace. So basic reaction chemistry is zinc carbonate. You first have to remove the carbon, make it into zinc oxide, and then again reduce the zinc oxide to zinc. So basic chemistry is this. How did they achieve that? They achieved it using this apparatus, which was indigenously invented, which is nothing but two different pots, mud pots. One of the pot buried deep in the earth, not very deep, just a few centimeters deep, with its face facing opening upwards, with another pot in which all the zinc ores are stuffed inside, along with several carbonaceous substances like the herbal materials. You stuff it completely on the top pot, invert it with small hole facing downwards and with its opening entering the downward pot. Okay, and then you fuel, you burn it, you apply heat from the top. So what happens? The reactions go on inside the pot, and whatever I said in the previous equation, the zinc carbonate gets converted to zinc oxide, then further gets converted to zinc. That does not escape out. It just percolates down, and down you have the temperature gradient. The liquid metal cools down to solid metal, and after a few days, when the fire has gone out, people come, they remove the top pot, dig out the bottom pot, and that's how you get the pure metal, zinc metal, 100% pure zinc metal. So this was how the zinc metal was obtained by our ancestors, and the archaeological remains are still found in a place in Rajasthan called Jhavarmala mines, where you can see them. And as I said before, unless a foreigner gives a credit, a foreigner certifies this achievement, we Indians will not be in a position to accept it. So here is Paul Craddock, I think, who was given also Padma Shri. And this is what he had to say. And I've underlined that many tens of thousands of tons of zinc was produced in our country. So much so that the earliest dated zinc mines in the world. And he also says that these are the earliest known zinc production center in the world. Okay. So if not for anything else, at least for zinc, we Indians can truly take pride upon for having supplied the world with many tens of thousands of tons of zinc. That is pure zinc. Now, this is very the processing the metal has not been a one-time affair for us. It's not that we were doing it by hit and trial and we forgot it and now we do not know. It is a continued tradition. So what I try to show you is something, a continued tradition from north to south. Those of you from Kerala will be immediately able to identify this Aranmula Kannadi near Trivandrum, a village called Aranmula. This here on the right hand side that you see here, this is from Rajasthan. This is called a Theva art. This is laying metal filigree art on glass. And the middle what you see is a jari work, which normally ladies wear for their silk saris. The jari work is made out of silk, gold threads, gold or silver threads. And each thread is something micrometer diameter. And that is done in a place where I am currently sitting in Banaras. So this processing the metal has been a continuous tradition. It's just that now they are all pushed to peripheries. Highlights from a few prominent texts. So, Rasarnava, this is a 12th century text. And see here what the text describes. I'll read it out for you. The procedures were described for making metal from Makshika, Vimala, Sasyaka. These are the three names of different ores of copper. The first two being pyrites, bearing copper, and the third being copper sulfate. And the wonderful observation was made that all the three red products seemed to be identical, that is tamra or copper. Mind you, this is not a very simple observation. What this author has to say, this observation made centuries before the discovery of elements and Daltonian chemistry cannot be belittled. So people, although they had known three different ores for the same metal, they had the knowledge that once you process these ores, which are looking very different, ultimately you will result in the same metal. Okay, so this is not something that one can, this is intuitively a leap of imagination to have this kind of a knowledge. Now in a text, same Rasarnava and Rasaratna, more in Rasaratna Samuchaya, we get descriptions of chemical apparatus. So most of the apparatus, you see them in the lab even today. Only difference is that today they are made out of glass. Back then they were made out of mud. So this is called a dola yantra, where you suspend something from the top with some liquid at the bottom being heated up, and then you either kind of, for hydrolysis purpose, you can carry out this, you can use this apparatus. On the extreme corner, you see the photograph of the apparatus, which I tried to get it made for my own department here for a conference that we had conducted a few months back. Similarly, this is the Tiryak Patana Yantra, which is a distillation apparatus. So you heat something on the top chamber, something vaporizes, those vapors travel down this pipe, and here you condense them and then collect those condensed vapors. So this is called Tiryak Patana Yantra, which is still used even to this day. This is Urdhva Patana Yantra, sublimation apparatus, where you make two pots. On the bottom pot, whatever substance you want to sublimate, typically mercury, they keep the mercury salt in the bottom pot, heat it, the mercury vaporizes, and those vapors you collect it on the top pot. The scaled up version of the Tiryak Patana Yantra is what is being still used in a place not very far from where I am. This place is called Kannauj, and Kannauj in UP is the perfume capital of the world. Normally people think France is a perfume capital of the world, but even to this France, Kannauj supplies a major part of the raw material for their perfumes. And even today, they use this Tiryak Patana Yantra for extraction of perfume from the flowers. Then there are descriptions of what are called as puta. Puta, rough translation in English, is equivalent to furnace. So there are interesting names like Mahaputa, Gajaputa, Varahaputa, Kupputaputa, etc. Each resembling a shape of these different animals that it is getting described. And each of these puta not just differs in the shape, but also the maximum temperature that can be attained using these putas. And what kind of fuels you need to use, and thereby what kind of temperature it will achieve, are all well described in these texts. Again, another quiz time to the students who are trying to, sleep away or getting distracted. I will read out the first few lines for you. I don't want you to tell me the meaning of it. Rather, try to guess what the author is trying to convey. Very, very approximately loose translation. Avartamane kanake pita tare sita prabha shulve neela nibha tikshne krishnavarna sureshwari vange jwala kapotabha nage malini dhumaka shaile tu dosara devi ayase kapila prabha, so on and so forth. Can you make a guess what the author is trying to say? Again, there are no negative markings. There is no marking for you to make a wrong guess.
Sir, the author is trying to give the color of the metals.
Can you please repeat yourself? Couldn't hear you.
Sir, the author is trying to give the color of the metals.
That's a very brilliant guess. Trying to describe the color of the metals. You are more or less 50% correct, but not completely correct. Any more guess? One more guess? But you have got it 50% right. Metals, colors.
Maybe the combination of different chemicals that cause the change in color of the chemicals.
Combination of different
Chemicals. Combination of different elements makes a change in their color. Maybe it's trying to describe.
Again, a brilliant guess, but no, this is not what the author is trying to convey. No.
So different types of diamonds.
Not really. No. In fact, this is the very first description of flame test. What will be the color of the flame when you introduce these metals? So the word avartamane is the word for introduction of gold will make the flame go yellow. Silver will make it go gray. Shulva, copper, will make it blue. Iron will make it black. So on and so forth. So you see, this is the first ever description of flame test, and I'm very glad that when you are in your school currently, when you will be doing excuse me, flame test, I am getting an opportunity to share this information with you. So that next time when you go to the lab and do the flame test, you should be able to feel proud that it's our ancestors who had very first described the flame test. Okay. And the accuracy to which these texts go in describing the completion of the process. Say, for instance, here, Navispulingo Najabudbudascha Yadana Rekha Patalam Shabdaha. What it means is, suppose the text is talking about purifying certain metal, and you have followed that step. You have purified the metal. Now, how to be sure that the metal that you have got is a pure metal? It prescribes certain tests. That is, it should not be bubbling. As it cools down, it should not bubble. Na vispulingo. Nacha budbudascha. Once it has cooled down, if you scratch it, it should not have any lines forming on it. Na rekha patalam. If you hit it, it should not be sounding. So like that, there are several tests that are prescribed by which you can repeat those tests and be confident that what you have done is, what you have obtained is a perfectly pure substance that is meant to be obtained. Not just that, they arranged the text, they arranged the metals in the decreasing order of reactivity. Suvarnam, Rajatam, Tamgam, Tikshnam, Vangam, Bhujangamam, Lohantu, Shadvidam, Tacha, Yatha Purvam, Tad Akshayam. Yatha Purvam, Tad Akshayam, Akshaya, that which does not decay. Yatha Purvam, so from before. So, Suvarna is Akshaya, followed by Rajata, followed by Tamra, followed by Tikshna. So, they had some kind of an empirical way to test the reactivities, and that's how they even arranged it. So, they had some quantitative approach also. It's not that blindly they were shooting in the dark. Now, perhaps I'll wind it up here because I know that I'm crossing the time now. So, I'll start maybe one of my last slides. Now, KTPI, of course, is written now, but we are also associated with NEP in some way or the other, where we time and again discuss about writing the textbook in a very interesting way. Now, here is one example where I would like to give you where how a scientific truth is written in a very poetic way. This is a picture that we see where elephant is trying to overpower a lion. And that's true also. Even though lion is the king of a jungle, a lion can become the king of a jungle only by killing an elephant. And a lion can kill the elephant only if it attacks from the backside. If the lion attacks the elephant from the front side, the lion cannot get killed. So the lion will get killed. The elephant will not get killed. The author here wanted to convey the fact that sulfur can react with all the metals, or sulfur can subdue all the metals. So he uses this metaphor of iron and elephant, and you see how beautifully he says this. Naso asti loha matango yanna gandhaka kesari nihantvad gandha nihanyat gandha matrena yadva makshika kesari. Naso na saha asti loha matanga. There is no elephant-like metal which cannot be subdued by sulfur-like iron. Okay? So to just convey a simple truth that sulfur is a very reactive substance, they make use of such poetic language, connecting the student to observe the nature in a more keen and more careful manner. Today, our aspiration is to also make students be more observant of their surrounding and also thereby study the scientific truths as well. Okay. Why? Because what are we trying to produce through schools and colleges? For that, again, I will take the example of C.V. Raman. C.V. Raman was invited by Rutherford, the famous Rutherford of gold foil experiment. Those of you who are studying in science, you may be knowing. Rutherford invited C.V. Raman to Cambridge, and C.V. Raman toured around the Cambridge, and after the touring around Cambridge, C.V. Raman was disappointed and told Rutherford that it seems to me Cambridge is a place for play and not for study. Why? Because when C.V. Raman was touring around, he saw students playing, he saw students singing, dancing, somebody working with carpentry, somebody working with goldsmithy, like that. This got an impression what C.V. Raman had, and when he told it to Rutherford, what is more interesting is to see what Rutherford replied to C.V. Raman. Sir Ernst turned around and said, "We do not try to grow bookworms here. We train men who can govern an empire." So remember the words of our Guruji also, who started a mission through his Jnana Yajna to come out of this kind of mental slavery, and at least through our now NEP and through such kind of modern Jnana Yajna that the mission is trying to arrange for you, each one of you must take it upon yourself not to just become a bookworm, but to excel in your individual life such that you are able to lead, you are able to govern an empire, no matter how big or small that empire is. Okay. So with that, I once again thank the opportunity given to me to share my few thoughts on chemistry, material science, and metallurgy to all of you. And with that, I once again apologize for the delay with which I started this talk. And if you have any questions, I'll be happy to answer them if I know them. Otherwise, I will be mailing them later after I find out the answer. Thank you very much.
Thank you so much, Ramanathan ji. I think you are an excellent teacher. You could directly connect with students and teachers, and I'm sure it's going to make a big difference for them. When they study in a textbook, it always has, it becomes a book, it becomes so passive. But when they listen to people like you and experts in this field, I think the knowledge becomes more dynamic and more vibrational. So thank you so much. And they normally do have a lot of questions. I request the students to unmute yourself, ask the question. Yeah. Yes, students, it's your time. It's somebody has said already, it's fascinating to learn. Can you ask your questions? So, as I always tell you, children, this is an opportunity for you to meet the best of people, coming and directly talking to you to make the best out of it. So you can ask your question. Anybody want to have any question? You can raise your hand so that you can unmute.
And as I tell in my class also, there are no stupid questions. There can only be stupid answers from me, but there is nothing like a stupid question. Okay, so feel free to ask anything that comes to your mind. So do not hesitate.
Yeah. Yes. Please have your videos on. Yes, Swarna ma'am, you can start.
Thank you, sir. Thank you for that freedom. So, recently, last year, under the guidance of Shanti ma'am and few others, Chinmaya Mission and then Vidya Bharati came up with the new textbooks for history. In that, tin root was mentioned, sir. So, tin root, I thought you can throw better light upon the tin root, how we were glorified about that. Even students wanted to know few more details about it.
The tin root is a newly, newly coming up topic. Tin, interestingly, the word for tin is Vanga. Trapu in the Vedic lore, it was referred to as Trapu, but Trapu goes out of currency and the word Vanga stays in. And interestingly, the word Vanga is also associated with the state, the Bengal. The Bengal comes from Banga and Banga comes from Vanga. Like Vaba, you have again Abheda. Like how Vihara becomes Vihara. So Vanga becomes Banga. And it is in that region that you have some tin deposits. So tin deposits are normally attributed to China and Italy, like mercury deposits. So India, not much of tin deposit was known, but still there was few deposits in the eastern part, and people were consuming it within the country. And people were also, I have not also read much about it. People were also exporting it outside. But tin as such was not put to use, but tin was always alloyed with copper to make bronze. As far as my study goes, that there is no artifact. Even only in the recent past, in the state of Jharkhand, there is a city called Jamshedpur, which is in fact the only industry in the whole country which processes tin. So beyond that, the tin route that talks about is how the trade was happening or how the tin was getting imported and exported. But I have to also myself read about it to establish which all countries it traded with. So beyond this, I'll not be in a position to share anything more on the tin aspect.
Yeah, that's a Tin Plate India company. It is there in Jamshedpur.
TCIL,
Yeah.
Tin Plate
Yeah.
Company India Limited.
Yes. They do work on it. Any other questions? Anybody else?
Ma'am, may I?
Yes, please.
A very thank you to you, Mr. Ramanathan, sir, for spending such a valuable time with us. It has been beneficial for us to receive such a beneficial information from you. So now my question was that were there any cross-cultural exchanges of chemical knowledge between ancient India and other civilizations?
Yeah, of course, there were. So much so that some of the historians were of the opinion that whatever knowledge we had, we did not develop it indigenously. We only borrowed it from the other civilization, namely Chinese and Persians. So on the one hand, we have such extremes where the historians were shying away from giving the credit to our civilization. So in short, yes, we interacted a lot with Chinese, we interacted a lot with the Middle East, the Persians, and there were give and take of knowledge happening. So there is no doubt about that. Yes.
Thank you so much, sir.
Anybody else? You can unmute and ask questions. Sir, can you also throw them some insight as to what kind of projects they can work on it? You have seen the chapter that I sent to you also,
Yeah.
and definitely you took them beyond the textbook. What kind of projects these are all class 11 students, say about 15, 16 age group. So what will be the right projects that they can work on?
One of the projects that I always insist on is going back to the text. See, they must be also having some Sanskrit language course with them. If not, also they can form a group with some people who know Sanskrit or with a Sanskrit teacher. Take up a text, not the entire text, take up 2 or 3 verses, try to interpret them. If it is describing a process, try to reproduce that in the lab. To start with, you can start with even the Charaka Samhita or Sushruta Samhita text, where simple addition of 2 different salts, how the color will change, how the pH will change. Those things we can immediately do it in the lab. So for that, but we need somebody to read the text, not go by just the English translation of the text. I didn't have time to cover, but in the same Arthashastra text itself, if you look at the English translation, it gives you one meaning. If you look at the Hindi translation, it gives you a slightly different meaning. So it's always good to go with the original text. And this is a young age, right age for you to get into the habit of getting into our original text. It will be difficult, no doubt. But with the help of somebody who knows Sanskrit, sit with them, discuss with them, then take up one shloka at least in that particular chapter and try to see if we can reproduce that in the lab. Like for instance, in one chapter of Arthashastra, in order to test the gold, verse comes Pushpakasi Sena Gomutrena Bhavitena. So it talks about Pushpakasi, sir. So if you are smart enough to refer to the Sanskrit dictionary, you will come to know yourself that Pushpakasisa means ferrous sulfate. Otherwise, you need to ask a Sanskrit teacher. And it says you take Gomutra and then you add the ferrous sulfate to Gomutra. Now what you can immediately do, you can measure the pH of Gomutra. If if it is difficult to access Gomutra, start with water. Measure the pH of water. Add this ferrous sulfate to the water. Then measure the pH again. See what happens to the pH. This is something that can be done very simply in the lab within a matter of few minutes. So the bottom line is there are thousands of such instances available in the text where you can take up and you can kind of replicate the process also in the lab. So this I believe can go a long way in nurturing right interest in this kind of a subject. The other shortcut method is, I give you some English translation of making certain things. That I believe is not very, very effective in my personal opinion, because more often than not the English translations are not very accurate. So if I were to strongly advocate, I would say take up even at least one verse, which is nothing but 2 lines. That's all, and that will keep you engaged at least for a month.
So just curious to know, how does it impact? What is the outcome when the Gomutra is tried on the one which you gave an example?
That example is part of my own research.
Okay.
It has got a background because, again, the historians, and Krishnavani ma'am asked about the cultural exchanges, right? So
Yeah,
we have been alleged that we did not have the knowledge about mineral acid until, say, 15th century. We knew acids. The term for acid is amla. Amla. But we knew acids only from organic sources, like citrus fruits, tamarind, pomegranate, so on and so forth. But we did not know mineral acid. Part of my research is there are certain processes that are described in the text which you cannot do away without using mineral acid. So this verse that I showed you was a part of that one process to process gold. So where I show that you see the mineral acid is getting formed in C2. If the pH is 7 in the beginning, if I add ferrous sulfate and the pH comes down to 3, that means mineral acid is getting formed.
That's true.
This impact has got.
Yeah,
this
right.
example was at the top of my head, so I gave you. But like that, there could be hundreds of many such examples.
Yes, and also the gold is utilized in the the expeditions, the things they're working on, space and all of that. So did you have any insight onto that? The space science, they use gold as a tool there.
They use gold for reflection purposes. See, gold is a very good reflector.
All right.
So when you want a space mission, some of the vital components to be protected by certain cosmic rays, because outside, when we are on the surface of the Earth, we are protected by the ozone layer, we are protected by the atmosphere, which filters out a lot of harmful radiation. But despite that, people get skin cancer because of overexposure to certain radiation. But once you cross the atmosphere, go into the space, there is no such protecting layer. So when you want to protect certain things, you want to reflect away maximum thing from reaching that. So there they use gold surfaces.
All right.
So, and then gold is also a very good electric conductor, thermal conductor. So wherever you want to have, with the least resistance, good conduction, they use gold. So in the circuit components, they use.
Anybody else having any other question?
Sir, I have a question.
Yeah, please.
Like our sisters say, you should eat in a silver plate with a golden flower. What are the benefits apart from the reaction?
Can you please repeat? I couldn't hear you properly.
Like we believe that we should eat in silver plates. So what are the benefits?
Eating in silver plates.
Eat in silver plates. Okay. Well,
sometimes they have a gold also pasted in the silver.
Yeah.
They have gold coins pasted.
All said and done, gold and silver are antimicrobial. Okay. Food is something that we need for our nourishment. But we are always having our competitors in the form of microorganisms who would like to have competition with us in consuming the food. Sometimes so much the competition is so high that we ourselves become food for the microorganisms. So when that's why back in those days where you did not have refrigeration, where the food was getting spoiled, it was advised that you use silver vessels, if not silver vessels, at least other metal vessels, like at least copper vessels, in which basically it is having the anti-germicidal properties. One example I can give you from London, just a few years back, not very many years back, there was a government policy that they will cover all the hospital beds using copper. Because hospital is one such place where they treat diseases, but is also one of the source of many diseases. Many infections are spread from hospital. So, but they found that if you have a copper surface, the copper surface acts like a germicidal. So that is one major reason why food products, and especially even in today in our culture, even no matter how poor the family is, if the kid is born, for a new kid, for an infant, within a few days, few weeks old kid, they try to feed the kid. I mean, if the kid has started eating solid food, it has weaned away from the mother's milk, they start feeding with silver spoon and feeding the kid with a silver cup. It is for basic reason for germicidal properties, nothing else beyond that.
Mr. Ramanathan, we have also other schools, some Amrita Vidyalayam, Trichy, and then Arya Gurukul, they all join us. They're all. So one student is asking anything about the Amrita Dhatu. This Amrita Vidyalayam is asking, one student in the chat box.
Amrita Dhatu.
Yeah.
Frankly, I'm hearing this word for the first time. But what I can tell you is that the word Amrita, Amaratvam, is to attain immortality.
Right.
So, what is immortality in the chemistry context? That is something which is very inert, like all the inert gases, helium, neon, argon, krypton, xenon. Since their octet is complete, they are hardly reactive. They have attained their immortality. Similarly, in the context of alloys, and interestingly, our text described them in that way. See, copper is reactive, but the moment you convert copper into brass or bronze, the reactivity reduces. That is, it is much more stable. So there, the Granthakara or the text, the author describes it as though the metal, the dhatu, has attained amaratva. So it is in that context the dhatu becomes amara. And that's why perhaps it may be amara dhatu, but this is just my conjecture, my guess. Perhaps you may be referring to something very specific called amara dhatu, but I'm sorry, I have not come across that yet. I have to see it for myself. Beyond that, I will not be in a position to throw light on it.
Yeah. We have one last question from Chinmay International School. With that, we'll close the session.
Hariam, sir. Sir, am I audible?
Yep.
Yes, sir. So the last known famous artifact made out of wood steel is Tipu Sultan's sword, which is right now in British Museum. But then after that, the process of making wood steel has completely gone extinct in India because many of the people who are doing it shifted to other lifestyles due to colonialism. Is there any research or any ways that which is going on to bring back the process of producing wood steel again?
Very good question. But to your knowledge, it is still not gone extinct. People still make wood steel, but of course not in a massive scale. Now there is confined to only few tribal people, quote unquote tribal. I don't want to use the word tribal in a derogatory sense, although today it means only in a derogatory sense, thanks to the British survey census taking practice that termed them as tribals in a derogatory way. But today there are Agaria tribe, Then there are one Agadia tribe is there. Then one Asur tribe is there. They still continue to make the weapons using the wood steel. Because today swords are not in demand for any warfare. Today you and I will not go to a battlefield with a sword. Battles are not fought today using swords. They are fought using different kind of mechanisms, either social media or through atom bombs. So that's how battles are fought today. So that's why you don't get to find such things in large scale production. But yes, they are getting produced. Second, the research behind them, I was fortunate enough to get associated with one person called R. Balasubramaniam, who unfortunately died very young, a professor in IIT Kanpur, who was researching it. Then there was one Professor Ballal in IIT Bombay, who had done good amount of research on it. Then IG Kalpakam in IG Kar in Kalpakam, Tamil Nadu, they did some research on it. Then, of course, in NML Jamshedpur, there was a group which was doing some research about it, but I do not know how did they progress. To answer your question in a very brief way, yes, people, metallurgists, they are doing some research about it, but you are right. We have to bring the process in the mainstream and perhaps not to make swords because swords are out of fashion now, but to make durable steel. Durable steel is of even now high demand. So much so that if Ratan Tata or Lakshmi Ellen Mittal comes to know about this process, they'll be paying you like anything. Because even to this day, producing reproducibly is an open-ended question, even in the state-of-the-art metallurgy. Because of the tiny window in which carbon has to get added, between 3 and 4%. That is something very difficult to get achieved.
Yeah.
Okay.
Okay. There's one last thing somebody has mentioned. And that girl from Amrita Vidyalayam that the student has mentioned, Amrita Dhatu is mercury they are talking about. That's what she says. And also clarified that. And what about the aluminium?
Yeah, I read the question in the chat
early
box.
days. Yeah, you can.
The people did not know about aluminum. Aluminum is a very recent discovery. That's what my reading is to this day, because aluminum is also very light metal. So back then, Indians, at least till my reading till now, or my readings till now, has not informed me about aluminum being in vogue back then. But it's a good point for me from this lecture to look into the provenance of aluminum. Thank you for that. Yeah.
Thank you so much. So we are really extremely thankful, Mr. Ramanathan ji, for your wonderful session. I think it has been completely, children could connect with you so easily. You could see the number of questions they had. I think some students want to thank you. Who is that? Meena, you mentioned?
A child from Kasaragod.
Kasaragod, they wanted to
Kasaragod
thank.
Vidyalaya.
Hello, ma'am. I'm from Chinmaya Vidyalaya. My name is Izaza. So, respected CCMT Director, Mr. Shanti Krishna Murthy, Coordinator Meena Madam, today's speaker, Honorable Dr. V. Ramanathan, Assistant Professor, Department of Chemistry, IIT, Banaras Hindu University. Dear students and teacher, Hariom, today's section was very informative. As we are new to this topic, we found it very difficult to understand about chemistry in India. Today, Dr. Ramanathan has cleared most of our doubts in chemistry in India. We are thankful to Mr. Ramanathan, sir. On the behalf of the entire Chinmaya Vidyalaya and CCMT, would like to thank you, or heartfelt thank you, sir. I also thank Shanti Krishna Murthy, ma'am, for providing this opportunity. Thank you, madam.
Welcome.
I thank this opportunity. Thank you, Meena madam, who has coordinated and present at this program. I also thank Priyanka ma'am and also other teachers and students from the various schools. I also thank other people who are involved in this section. Thank you, Jai Bharat.
Thank you. Thanks to everybody. I think a lot of people are working behind this program. Amrita Vidyalayam Nagai, you want to say something?
Yes, ma'am.
Yeah.
I'm Sharmila of class 11 from Amrita Vidyalayam Nagapattinam. First of all, thank you for this session, ma'am. It was more useful and informative for us. We have learned a lot of information about the lesson and also got more details about all the technologies and scientific facts, which will be really helpful for examination. And it also helped us to develop more interest toward the subject and the lesson. Once again, thank you for your clear and detailed explanation, sir. We are eagerly waiting for the upcoming sessions, sir. Thank you.
Thank you. Thank you. Don't just study for getting marks. Look at the glory of the subject, and I am sure it will make a big difference. And any teacher, finally, any teacher who has joined here can offer your thanks. Then we can wind up. Swarna ma'am from Chinmaya International School. Yes, ma'am.
Hariom ma'am, Hariom sir. It's a wonderful session. I could reconnect to my childhood. I heard so many words after maybe 20 years, sir. Mailu tuttam. Mail in southern languages means peacock. And then tuttam, I could connect it. Blue in color, sulfur. And then my grandfather used to use it in Maida. He used to do the binding work, self-binding work. So it was useful for him. The Maida was not getting fermented or something. So like this, so many words, sir. And then Gandhakam also. So it's easily connected, sir. We could make out so many questions, and then my children also have got the interest to do some project. We will search for a shloka, try to interpret and get back to you through Shanti ma'am, sir. Thank you very much.
Thank you so much. Thanks to all of you. You can post me, the teachers at least can let us send a mail. What would be the next chapter that would you like to have? Thank you again, Dr. Ramanathan ji. A lot of people have mentioned to me that they want to see this recording. Michelle has sent a special request saying, I have to listen to this. Please send it across to me. I'll be sharing it with others. Thank you so much once again from Chinmaya Mission and from all the schools. It is making a big difference. In fact, CBSE also wants to post it in the group so that the other children can understand how the whole subject is tuned towards. Thank you so much for being a part of this wonderful mission and taking this journey forward. Thank you so much. Children, let's sit together straight and say the Shanti part and close today's meeting. Purnamadah Purnamidam Purnat Purnamudashate Purnasya Purnamadhaya Purnameva Vasishyate. Om Shanti Shanti Shanti. Harihi Om Shri Gurubhyo Namaha. Harihi Om. Thank you so much once again, sir. Thank you, sir.